we are supposed to find the shaded area. The dimensions are in centimeters, and we are supposed to use 3.142 as our pi. So the first thing we do is to get the measurements of the rectangle, and we can only do that by equating the two opposite sides which are said to be equal. We know the length of a rectangle is equal to this other length here, and then the width is equal to the width. Now, starting with the length, we shall say this algebraic expression is equal to this one here. Now, if we take this 10y across equal signs in an effort to put like terms together, we shall have 6x plus 3y minus 10y is equal to 40. Then plus 3y minus 10y gives us minus 7y. So we shall have 6x minus 7y is equal to 40. This gives us the first simultaneous equation. Now we also relate the widths. We shall have x plus y is equal to 2x minus 10. If we take these 2x across equal signs, we shall have x plus y minus 2x, because when it crosses equal signs, it changes to minus 2x, is equal to negative 10. Putting like terms together, we shall have x minus 2x plus y is equal to negative 10. X minus 2x gives us minus x, then plus y is equal to negative 10. This gives another simultaneous equation. Now we solve these two pairs of simultaneous equations. If we take them together, we shall have them look like that. Now you can use many methods to solve this. I've discussed them in around 4 videos about the same. You can use substitution method, elimination method, we have a graphical method, and then of course we have the other one, which is a matrix method. So if you use substitution method, where you take the second equation and make y the subject of the formula, we shall have y being equal to this minus 10, and then when this minus x crosses equal signs, it changes to plus x. Don't forget to insert brackets, because the whole of this expression represents one quantity. We have used this second simultaneous equation to make y the subject of the formula. Now take the remaining simultaneous equation, which is the first one, where you see y, substitute it with this expression. So we take the first one, which says 6x minus 7y is equal to 40. Substitute this y with this, we shall have 6x minus 7 into negative 10 plus x is equal to 40. If we open this bracket, we shall have 6x minus 7 times minus 10 gives us positive 70, minus 7 times plus x gives us minus 7x is equal to this 40. Like terms together, we shall have 6x minus 7x giving us minus x, and then plus 70 is equal to 40. Take this positive 70 across equal signs. If we take this positive 70 across equal signs, we shall have minus x being equal to this 40 minus 70. That means minus x is equal to minus 30. But we want x, we don't want minus x. So the only way we can get out of this is either we multiply both sides by negative 1, or we divide both sides by minus 1. I've decided to multiply both sides by minus 1, and when we do that, we shall have it look like this, such that minus 1 times x gives us x, and then minus 1 times negative 30 gives us 30. That means our x is 30. Now, use the first simultaneous equation, or the second one, or even this one, where you see x, substitute it with 30 to help you get y. In our case, I've decided to use this, so we shall take y being equal to minus 10 plus x, substitute 30 here, we shall have y being equal to minus x plus 30, and that means y is equal to 20. So we have a value of x as 30, the value of y as 20. We can now go back to the this rectangle here and substitute those figures there, and we can be able to get the length and width. Now I've decided to take this algebraic expression to assist me get the actual length, and this one to assist me get the width. So starting with the length, we shall say the length of the rectangle is given by 10y plus 40. But remember, we have found y to be 20. So that is equal to 10 into 20 is 20 here plus 40. And of course, this is 200 plus 40, which gives us 240 centimeters. That is the length of the rectangle. The width will be found by this algebraic expression. I said I've decided to use this one, 2x minus 10. But our x is 30. So that means this is equal to 2 into 30 minus 10. We substitute 30 here. So we have 2 into 30 minus 10. And this is the same as 60 minus 10, giving us 50 centimeters. That is the width of the rectangle. Now, having gotten that, we need to get the hypotenuse, which actually in the real sense represents the radius of the semicircle, so that we can be able to get the area of the semicircle. So we shall say the radius of the circle is given by Pythagoras. We shall get that using Pythagoras theorem. Now, in this Pythagoras theorem, how do we use it? We shall take the center here and we draw a line to one of the corners, either this or this. If we do that, you realize this length from here to here is a radius of the semicircle. At the same time, if we consider this triangle here, you realize that this red line, the radius is the hypotenuse, this is the height, and this is the base. Don't forget that we have calculated the length and found it to be 240. From here to here is 240. But don't forget that from here to here is half of this distance. So that means from here to here, which is the base of this triangle, is 120 centimeters. The height is actually the breadth or the width of the rectangle, which we have found to be 50. So we are looking for the hypotenuse. Now let's use the measurements down here. We shall say base squared plus height squared is equal to hypotenuse squared. Our base squared is what I've just mentioned to be the length from here to here, which is 120. So we take 120 squared plus our height is the distance from here to here, which we have said is the hypotenuse, the width of the rectangle. We found it to be 50. So 50 squared is equal to hypotenuse squared, which in the real sense is the radius we are looking for. Now, if we square that, we shall have this giving us 14,400 plus 2,500 is equal to hypotenuse squared. Adding the two, you get 1,6,900. 1,6,900 being equal to hypotenuse squared. Look for the square root on both sides. We get hypotenuse is equal to 30 centimeters. This is the radius of the circle, or the semicircle in this case, because we only have a semicircle, half of it. Now, how do we get the area of this semicircle? We shall say the area of the semicircle is given by half pi r squared, which is equal to half times our pi. We were told to use 3.142 times the radius, which we have just found here, and we said it's equal to the hypotenuse. So it is times 130 times 130. If you do that, you get the answer being 26,549.9 square centimeters. Then the rectangle. What about the area of the rectangle? Area is given by length times width. Our length is actually 240. The actual distance from here to here, not 120. It is the actual distance from here to here, which is 240. We had calculated it somewhere here. The length of the rectangle is 240 and the width is 50. So we shall say area is equal to 240 times 250 times 50, sorry. The length, which is 240, times width, which is 50. If you do that, you get 12,000 square centimeters. Now, how do we get the shaded area? Shaded area is found by taking the area of the semicircle minus the area of the rectangle. So you can say shaded area is equal to the area of the same circle, which you have just calculated here and found to be 26,549.9, minus the area of the rectangle, which is 12,000. And when you do that, you get 14,549.9 square centimeters. That is the shaded area. Thank you.